Hey everyone, welcome back to the channel. Today we are exploring graph databases, a database model specifically built around relationships. If you have ever struggled to map highly connected data in traditional databases, graph databases might be exactly what you are looking for, like for like a social media application or something like that, like Facebook use a graph database. So, as always, we try to answer the question of what. What is exactly a graph database? A graph database represents data in terms of nodes, like which are like entities, and edges, which describes the relationship between those entities. Unlike a relational database with tables and rows, or document store with JSON documents, a graph database are optimized for relationships. Things like Alice follows Bob, or like maybe X follows Z. It's like we have order, or something like order belongs to user, or product is in a category. It's something like that. It's built based on relationships. As you can see here in a graph database, we have three things. First, we have the nodes. And the nodes, these are your primary data elements, such as user, documentation, graph database, or user, products, location. And we have edges. The edges are the connect. It's basically it connects nodes and often include directions like user read read and write and read this document. It has some sort of like a, has some sort of like it has some sort of direction, like X follows Y or X contains Y, something like that. Plus, also we have some what we call properties. It's like timestamps or wait, like properties. Both nodes and edges can have key value pairs to store additional data if we wanted that. Um, because relationships are first class citizens, queries that involve joins and hops between connected entities can be done very efficiently and way more easy. So why to use a graph database, or when to use a graph database? A graph database shines in scenarios where connections between data points are quite crucial, like in social media applications or social network, like analyzing friendships, follows, or professional connections in real time. Also, it shines in recommendation engines because suggests to friends or products or content based on user similarity or shared interests. Also, it works great in fraud detection, like identifying suspicious activity through patterns in financial transactions or user interactions. Um, yeah, I would say this where the why question actually really matter, and in these cases, it's quite a good idea to actually use a graph database. The next thing that I would like to talk about which is how the graph database differ from relational database. The first thing in the relational tables, we have what we call tables, which have like rows and columns. Oh, column. And also in relational database, there is joins, which to relate data to each other. And there is performance can degrade with complex joins across many tables. In the graph database, we have node, we have edges, and and we have properties. Relationships are stored natively, and queries can traverse large connected data sets with speed and simplicity. In a graph databases, you model your data around the relationships instead of forcing them into a table based schema. This can like drastically reduce join complexity and improve performance for certain workloads. There are a lot of popular data graph databases. I guess one of the most famous one of them is like a new 4J. It's one of the most famous. Also, there is Amazon Neptune. What else? I don't know. But I guess yeah. There is a few popular them, like 5 or 4 things, but what comes to mind only these two right now. I guess next we need to talk about like best practices for this introduction, like a best practice for graph databases. So in the best practices, I maybe have some. Okay, let's see that I have only 4 advices to give now because it's an introduction. It should be like beginner friendly, so I will not go deep into it. I would say first you need to design for relationships first, like identify your main entities like nodes and the connections, which is the edges you need to query. Number two, keep nodes and edges lightweight, like store heavy data, images, large text externally if possible. Keep your graph lean for faster traversal. Number three, index important properties. Like if you frequently match on a particular property, have index. For example, like a category if you have an e-commerce, or maybe I don't know, email or something like that. You need also to plan for growth. Like graph databases scale horizontally, but be mind of sharding strategies if your data volume is massive. But I would say that if you are working with a famous database system, it will do this for you out of the box, so you don't have to think about this one. But in terms of system design interviews, you need to know how sharding or how to handle sharding in your graph database. I guess this is the end of our video. It was a lightweight, short video, and yeah, so that's it. And see you in future videos.